Hello and welcome to EduSathi. Continuing the topic of quantitative reasoning, we'll be moving to the second part and we'll discuss about divisibility rules, factors and multiples. Let's look at the concept of divisibility rules first. Divisibility rules help us in determining whether a given number is divisible by a divisor without actually performing the division. And we usually do it by examining the digits. So it's very simple. Instead of actually dividing the number, we'll follow the divisibility rules and we'll check whether a given number is divisible by a divisor or not. In case it is not divisible, we'll also be able to find out what is the remainder. So let's look at the divisibility rules for certain numbers. Now, if I have to check the divisibility with 2, I would not look at the entire number, I would only look at the last digit. So if the last digit is divisible by 2 or is 0, the entire number is divisible by 2. So for example, the number that you have is 4634. So I will not check the divisibility for the entire number, I will only look at the last part, which is 4. 4 is divisible by 2, so that means this entire number is divisible by 2. So divisibility rules for all powers of 2 would follow a similar rule. So this is 2 raised to power 1, 2 square would be 4, 2 cube would be 8 and so on. So if I have to check the divisibility by 4, which is what? 2 square, I would look at the last 2 digits. Here I am looking at last digit, here I am looking at last 2 digits, here I am looking at last 3 digits. So I look at the last 2 digits. If they are divisible by 4 or they are double zero, the entire number is divisible by 4. For 8, I would look at last 3 digits, check its divisibility with 8 if they are divisible, or if the last 3 digits are 000, the entire number is divisible by 8. Let's move to the divisibility rule for 3. Now, what I would do, I would find out the sum of all the digits, and if I look at the sum of digits, it should be divisible by 3. So again, if I take this same number 4634, and if I look at the sum of digits for all of these numbers, it is coming out to be 17. Now if I look at 17, 17 is not divisible by 3. So that means this entire number is not divisible by 3. Now in case I have to check the remainder that 17 gives with 3, and if I divide 17 with 3, I get a remainder of 2, because if I write it as, this is 5 into 3, 15 plus 2. So I get a remainder of 2, so that means I can also find out the remainder without actually dividing the number with 3. Similarly, the power of 3 would follow a similar rule. So if I look at the power of 3, which is 3 square, now what I'll do is I'll find out the sum of all the digits, and that sum should be divisible by 9. So if the sum of the digits is divisible by 9, the entire number is divisible by 9. Let's look at the divisibility rule for 5. I will look at only the last digit. It should be either 5 or 0. So the last digit of any number, again I take this number 46434, the last digit is either 0 or 5, the number is divisible by 5. Now if I look at the divisibility rule for 6, 6 is not a prime number, it is actually a product of two prime numbers 2 and 3. So if I have to check the divisibility rule for 6, I would check for its divisibility with 2 and with 3. The number has to be divisible both by 2 and 3 for it to be divisible by 6. Let's move ahead and let's look at the case of 10. The last digit should be 0. So if the last digit is 0, the number is divisible by 10. By 11, now this is very interesting. I will form two series of alternate digits. The second step would be sum of the two series is what I will concentrate on. So the sum should either be equal, that means the difference should either be 0 or a multiple of 11. So if I just take the same number 4, 6, 3, I'll form two series of alternate digits. These are the series. 6 plus 4, this series sum is 10. 4 and 3, this series sum is 7. So 10 and 7, the difference between 10 and 7, 3 is not a multiple of 11. So that means this entire number is not a multiple of 11. If I have to check the divisibility with 12, 12 again being a composite number will not have its own divisibility rule. I'll have to break it down. So I'll break it down into two numbers which are co-prime to each other. That means these two numbers should not have any common factor. That is very, very important thing. I can't break it into 2 and 6 because 2 and 6 have 2 as a common factor. So the number should be both divisible by 4. That means I'll look at the last two digits, and 3. That means I'll look at the sum of digits. Let's look at some of the questions based upon the divisibility rules that we have just learnt. If the number 357A25B is divisible both by 3 and 5, then the missing digits in the unit place and the thousand place respectively are. So first I'm writing in the unit place B and then A. So to answer this kind of question, I should remember the divisibility rules for 3 and 5. Now what is the divisibility rule for 5? The last digit should either be 5 or 0. So the value of B would either be 5 or 0. Now if I look at all the options that I have, the two options, one with 0, another with 5. So basis only upon B, I cannot answer the question. So I'll have to look at A as well. So if I just look at it, divisibility rules for 3, I would have to sum up all the digits. So what do I have? 3, 5, 7, 2, 5, A and B. Now this is what I have to look at. I will find out the value of A and B such that the sum that becomes here becomes a multiple of 3. So if I just add up the things, this is coming out to be 19 plus 3, which is 22, plus A plus B. So the value of B could either be 0 or 5. So correspondingly, I will look at the value of A. So if I just remember the multiples which are there for 3, 22 is not, if I just write here 22 plus, now the closest multiple that I have is 24. That means the value of A would come out to be 2. Another multiple that I can have is again adding 3 to it. So this will be 5, 8 and so on. If I just look at this, none of the option is matching, right? So probably my answer would be between B and C. So if I start with 5, 22 plus 5 gives me an answer of 27. Right? Now, I just have to look at this value. What I add in 27 so that the number becomes a multiple of 3. 27 itself is a multiple of 3. So the number that I would be adding would also be a multiple of 3 to give me an overall number which is a multiple of 3. So my answer would be option number B. All these type of questions has to be done with the help of answer options only. Let's look at another option that we have. Just give me 1 second. Yeah, so let's look at the second question that we have. The number 311 is divisible by. So the number that I have is 311. And if I look at the answer options, 3 and 11 is what I have to look at. So I know the divisibility rule for 3 and I know the divisibility rule for 11. What is the divisibility rule for 3? Sum of all the digits. So if I just add them up, 3, 4, 5, 8, 9 and 10. So the sum of all the digits is 10. 10 is not a multiple of 3, so that means the number is not divisible by 3. The number is not divisible by 3. So this option is eliminated. Divisible by 3, this option is eliminated. So that means my answer is either B or D. So I'll follow the divisibility rule for 11. I know this is what I have it with 11. I'll form the sum of alternate digits. 1, 3 and 1, which is 5. 1, 1 and 3, which is again 5. So if I look at the sum of the two series, the sum of the two series is actually equal. That means the difference is 0. So the number is divisible by 11 but not by 3. Second is my answer option that I will mark. Let's look at another question. The question is, what should be subtracted from 3, 4, 5, 6, 7, 9 to make it divisible by 11? Now to answer this question, I should know the divisibility rule of 11. The divisibility rule of 11 is, I have to make two series of alternate digits. So this will be the digits that I will have. If I just add them up, this is coming out to be 19, and this sum 8 and 7 coming out to be 15. Now if I look at the difference, 19 minus 15, this is coming out to be 4. That means there is an excess of 4 which is there in this number to make it divisible by 11. So if I subtract 4 from this number, the number that I would get is 3, 4, 5, 6, 7 and 5. This number is divisible by 11. However, I'll have to look at the answer options. So I will have to subtract 4, this number is divisible by 11, and another subtract 11. So in total, I'm subtracting 4 and 11. That means if I subtract 15, I will lead back to the previous multiple of 11. So 4 will give me a multiple of 11. Another 11 subtracted would give me another multiple of 11. So in total, the number that I have subtracted is 11 plus 4, which is 15. Let's look at the fourth question. If P is divisible by 7 and Q is divisible by 6, so I can write P as 7x. That means it's some multiple of 7. It could be the first multiple, second multiple, nth multiple. And Q is divisible by 6. So that means Q is also a multiple of 6. Then PQ. So if I just multiply P into Q, what I'll get is 7x into 6y. So I can write it as such, or I can write 42xy. PQ must have at least how many factors greater than 1? So if I look at it, now for x and y, I'm not sure. X and y could be multiple of 2, 3, 4, 5, whatever, I'm not sure. So I can't predict anything about xy, but I'm sure about this number 42. So I'll try to break down 42 and look at the factors of 42. And the question is asking me greater than 1. So if I try to do the prime factorization of 42, 42 is divisible by 2, 42 is divisible by 3, it is divisible by 6, it is divisible by 7, it is divisible by 14, it is divisible by 21, and it is divisible by 42. So what you can do is, you can look at the various combinations that you can get from here. 2, 3, multiply them, 6, 7, multiply these combinations and multiply all of them. There will be all the factors that you will have for 42. So 1, 2, 3, 4, 5, 6 and 7. And I am not included 1 because the question is saying greater than 1. So my answer would be option number 4, 7. Now, we have discussed the divisibility rules for certain numbers, but we have not discussed them for numbers like 7 and 13. Right? So 11 I've already discussed. So let me take a number for 3, 5, 6, 7, 8, 7, 9, 8, 4 whose divisibility has to be checked with 7. Now what I'll do is I'll separate the number taking 3 consecutive digits like this. So I'll try to separate it starting from the back. So this is what I have. Now I will take one part of this, the last one, and subtract it from the remaining. So I subtract the last 3 digits from the remaining part of the number. So from 4043, 567, I'll subtract 986, and this is what the number that I'm left with. Again, I'll do the same thing. I'll take this part of the number, which is the last 3 digits, subtract it from the first 3 digits, and this is what the number is I'm left with. Now, if I look at 539, I'll have to check its divisibility with 7 in a normal way, but not 13. This number is not divisible by 13. I'll check its normal divisibility. Thus, the number is also divisible by 7 and 11, but not by 13. So if I have to check the divisibility using the same rule, I'll separate it into blocks of 3 consecutive digits, and I'll subtract the last block from the remaining part of the number. I'll keep on doing so till the time I get a 3-digit number, and for that number I'll manually check its divisibility with 7, 11 and 13. Another very important thing that I need to understand is dividend is equal to divisor into quotient plus remainder. This is a division verification rule that we have. Dividend is equal to divisor into quotient plus remainder. So for example, if I take a number 35 and I divide it with 4. Now 35 is not divisible by exactly by 4. It could be written as 4 into 8, 32 plus 3. So I'm dividing this number with 4. 35 can be written as 4 into 8 plus 3. So dividend is equal to divisor into quotient plus remainder. So if you remember dividend, this is divisor, this is quotient, and here what you get is a remainder thing. Let's look at an example. In a division sum, the divisor is 10 times the quotient. Now what is it? The divisor is 10 times the quotient and 5 times the remainder. If the remainder is 46, then the dividend is. Now if I just look at it, I know the remainder 46. So 5 times the remainder would be the quotient. So 46 into 5, which is 230, that will be my divisor. And divisor is 10 times the quotient. So if I just find out the quotient, this is 230, this is 10 times the quotient. This is 10 into quotient, the quotient that I will get would be 23. I'll have to just form the number. Number would be divisor into quotient plus remainder. This was divisor, this was the quotient, this was the remainder. So I just multiply all of them and add the remainder into it to get to my answer. A number when divided by 899 gives a remainder of 63. So what can be the number can be written as 899 is the divisor. There must be some quotient and there will be a remainder of 63. If the same number is divided by 29, now I am dividing this number with 29. So if I just divide it with 29, 899k plus 63. If I just look at it, I can always separate the numerator. Now if I look at it, 899 is exactly divisible by 29. So this thing can be cancelled out. So if this thing is exactly cancelling out, the remainder would be 0. Because the numerator is a multiple of denominator. What I am left with is 63 divided by 29. So if I just divide 63 with 29, I can see that 29 second multiple of 29, which if I just solve it out comes out to be 58. So 63 can be written as 29 into 2 plus 5. So my answer would be, I am getting a remainder of 5 because 899 is anyways a multiple of 29. That would not give me any remainder. So I'll write 0 plus 5. So the final remainder is 5. Let's look at another question that we have. The number when divided by 6 leaves a remainder 3. So what is it? A number when divided by 6. There must be some quotient and the remainder is 3. When the square of the same number. So what I do n square. This I can write it as 6k plus 3 whole square. So this will be 36k square plus 9 plus 2 into 3 into 6k. When the square of the same number is divided by 6, then the remainder is. So I divide this number with 6. Now if I look, 36 is already a multiple of 6, so the remainder would be 0. I can just remove this out. Again, this number is a multiple of 6, so the remainder would be 0. The remainder that I would get would only be from this case. 9 when divided by 6 gives a remainder of 3. Seventh question is, when the positive integer n is divided by 3, the remainder is true. So I can write n as 3k plus 2. And when n is divided by 5, the remainder is 1. Now this will be 5. I will not use the same k because the quotient will not be same. 5m plus 1. What is the least possible value of n? Now these type of questions I can do with the help of options instead of actually forming the equations. Now I'll just have to look at the answer options. I will have to look at divisibility with 5 yields a remainder of 1. So it cannot be 8, it cannot be 17 or 18. So because when I am dividing a number with 5, I get a remainder of 1. So the answer option would be either 11 or 6. Now I'll check the divisibility with 3. 6 is anyways divisible by 3, so that will not give me the answer. My answer option would be option number C. So I will not form any equations. I will just look at the answer options and I'll solve it out. Another question. The product of 3 consecutive integers is 2, 1, 0. Then their sum is 3 consecutive integers. In consecutive means the integers are just one after another. So if the one integer is x, another will be x plus 1. The third I'll write it as x minus 1. Right? So it is asking me the product of 3 consecutive integers is 210. Okay, perfectly alright. Then the sum is. So I'm just summing them up. So if I just look at this, this is 3x. Whatever is the value of sum that I will get, it will always be a multiple of 3. So I'll just look at the answer options and I'll decide. 17 cannot be the answer because it is not a multiple of 3. However, 15 can be an answer option that I have, 18 can be an answer option, 21 can be an answer option, 27 can be an answer option. So I'll move according with the option and find out the value of x in each case. X here comes out to be 5, x here comes out to be 6, x here comes out to be 7, and x here comes out to be 9. Now what I'll do, I'll try to see where I get a product of 210. So if I just look at 10 in the end, there has to be 1 5. So if I just look at the answer options, so if I just try to form this, this will be 4 into 5 into 6. If I take the value, this will be 4 into 5 into 6 that I will have. However, if I try to break 21, I can write this as up 7 into 3 into 5 into 2. This is what the breakage of 210 is. 21 into 10. So this is 21 into 10. I can just combine this thing up. This will be 5 into 6 into 7. I'm just writing. So that means my answer will be option number C. Because this is not getting a multiple of 7 anywhere. If I just do it, this will be 5 into 6 into 7, which is a multiple of 5 and 6 and 7. So my answer is option number C. Another question. When 2 raised to power n is divided by 3, remainder comes out to be 1. Where n is an integer, which of the following is true? Now, all these statements could be true, 2 could be true, 1 could be true. I'll have to check all of them. So what I'll do is, I'll take the values. 2 raised to power 1. When divided by 3, 2 divided by 3, the remainder is 2. When I take 2 square, which is 4 divided by 3, the remainder is 1. So this is the case, 2 square that I have. 2 cube, if I look at, is 8 divided by 3, the remainder is 2. This is not the case that I look for. 2 raised to power 4, which is 16 when divided by 3, the remainder is again 1, the case that I look for. So the value of n is coming out to be 2, 4. If I just go on like this, it will be 6. If I can just check for 6. 2 raised to power 6 is 60. If you just look at it, 64. 64 when divided by 3 gives a remainder of 1. Perfectly alright. 8 and so on. Then Then what is the question asking you? N square plus 1 is a multiple of 3. So if I just look at this, 2 square, which is 4 plus 1, 5. 5 is not a multiple of 3. If I just look at 4 square, 16 plus 1 is not a multiple of 3. 36 plus 1, 37 is not a multiple of 3. So this statement is not true. The value of n which is coming out to be even in all the cases. So if I just look at it, 3 raised to power n minus 3 raised to power n, since the value of n is even, this minus thing will be nullified to give me the second statement, which will definitely be true. Let's look at the last statement, 2 raised to power n. N is always a multiple of 2. So if I divide this, I'll write it as 2k divided by 2. So this will definitely come out to be integer because n is always a multiple of 2 and the power that I will get for 2 will always be a whole number power. So when I solve it out, it will always come out to be a integer. So statement number 2 and statement number 3 are correct for the question that we have. Another question that we have is, what is the minimum number which when divided by 4, 6 and 8 gives a remainder of 2, 4 and 6 respectively? Now what I can do is, I already have the answer options with me. So I can first scan the answer options and get to my answer. Now divisibility with 4, I look at the last 2 digits only, gives me a remainder of 2. So if I just look at the multiples of 4, 24 is a multiple of 4, cannot be the answer, right? 28 again is a multiple of 4, so cannot be the answer. So if I just look at the numbers, 22 gives a remainder of 2 when divided by 4, 26 also and 30 also. So these are the 3 answer options that I have as of now. Now when I divide it with 6, the leftover answer options, if I just look at it and look at the remainder with 6, 18 is divisible, I get a remainder of 4. The nearest multiple of 6 is 24. So when I look at 26, this does not give me a remainder of 4, right? When divided with 6. If I look at 30, 30 is anyways a multiple of 6. So I'm just left with what? Which answer option? 22. That is the correct answer option that I have. So eliminating the options is the best method that you have in solving the questions. Let's move ahead and let's talk about factors and multiples. Let's study factors first. Factor of a given number are a set of numbers which are less than or equal to the given number which divides the given number completely. So any number smaller than the given number which divides it completely is a factor. Factor leaves no remainder. Very, very important thing. A factor would never leave a remainder. Factors are the numbers that you multiply together to get the required number. So if I look at a number like 6 or 12, the factors would be 1, 2, 3, 4, 6 and 12. All these numbers are below 12 which divide 12 completely. So 12 is divisible by 2, it's divisible by 3, it's divisible by 4, it's divisible by 6 and it's divisible by itself. So all of these would be factors of 12. There can be many factors of a number and the number of factors are always countable. So you can always count the number of factors that you have. So the example that we looked at, the factors of 2 can be summed up as, and the product of equidistant factors give you the number itself. So it could be 2 into 6, it could be 3 into 4 and of course 1 into 12 that you have. So 1, 2, 3, 4, 6, 12 are the factors of 12 that we have. Also, minus 1, minus 2, minus 3, minus 4, minus 6 and minus 12 are factors because you get a positive number when you multiply two negative. Minus 1 into minus 12, minus 2 into minus 6, this. So they can be positive factors or they can be negative factors as well. Factors are never in fractions. Factors can be positive or negative whole numbers. Very, very important thing. Factors are always whole numbers. Factors cannot be in fractions. So if I look at the factors of 12, as we have just discussed, 1 into 12, 2 into 6, 3 into 4 would give you 12. And there are 6 factors that I have for 12, including 1 and including the number itself. If I exclude the number, I'll have 5 factors. If I exclude 1, I'll have 4 factors for the number 12. And product of equidistant factors give you the number itself. Very, very important thing to be always kept into consideration. Now let's talk about highest common factor. We've just talked about factor. The largest number that divides the two or more given number in the highest is known as the highest common factors of those two numbers. So I find out the factors of two given number. Whatever is the largest number that can divide both the given numbers simultaneously is known as its HCF. Now if I have to find out the HCF, what I'll do is I'll write the numbers in a prime factorization form and I'll look for the common factors. And I'll look at their powers. So I look for the common factors. Whatever is the common factors that I have, that will help me in finding the highest common factors. So if I just look at the numbers 72, 288 and 1080. So this is the prime factorization form in which I write down the numbers. So if I look at it, 2 is there, 3 is there, 5 is only there here. So if I just look at the indices will be 2 raised to power 3 because 3 is anyways there in all of them. And 3 raised to power 2 because 3 raised to power 2 is the minimum number that is available in all of them. HCF is given by lowest indices of the common prime factors. So I look at the common prime factors and I look at the lowest indices because that is the thing which is common in all of them. And I have to look at the common things. And HCF is also known by another name which is greatest common divisor or GCD. So whenever a question is there which is asking you to find out GCD, don't worry, it's the same question that is asking you to find out HCF. So these two words are used interchangeably, HCF and GCD. Now let's talk about LCM. LCM of two or more numbers is the lowest number which is divisible by all the given numbers. Unlike HCF, HCF is able to divide the numbers, whereas LCM is a number greater than the given numbers which is divisible by all of the given numbers. So if I have to find out the LCM, I will perform the same step of prime factorization. Then instead of taking the lowest indices of the common factors, I'll take the highest indices of all the factors. I'm not looking at only the common factors, I'm looking at all the prime factors. So if I have to find out the LCM of the same numbers, and if I just do the prime factorization form, it will be 2 raised to power 5, 3 cube and 5 raised to power 1. I will look at all the prime factors and I will look at their highest power. This will be the lowest common multiple. Multiple, unlike a factor, is always greater than the given number which is divisible by the given number. Now very, very important relationships that I have to remember when I'm looking at the case of LCM and HCF. Now the first being LCM of two numbers into HCF of those two same numbers is equal to the product of the two numbers. Very, very important rule. LCM into HCF is equal to product of the two numbers. This relationship is only valid for two numbers. This relationship is not valid for three numbers. Now, LCM is always a multiple of HCF. So if I know HCF, LCM will always be a multiple of HCF. Third one being, if I have to find out the LCM of fractions, I will split up the numerators and denominators. So I'll look at the numerators separately and denominators separately. If I have to find out LCM, I will find out the LCM of numerators divided with HCF of denominators. Or if I have to find out HCF of fractions, I'll just follow the other way round. I'll take the HCF of numerators and divided by LCM of denominators. So prime factorization, I hope you can all do that. So if you have to find the number of positive factors for any given number, I'll first write down in a prime factorization form and look at their powers. Once I have looked at the powers, I'll increment them with 1 and multiply. That will give me the number of positive factors. So if you remember the number 12, 12 can be written as 2 square into 3. So this is 2 plus 1, 3 into 1 plus 1 which is 2, 6. So I'll have 6 positive and 6 negative factors for number 12. So if you remember, these were the factors that I have solved out. This number of factors include 1 and n, and the number itself is included. Let's look at an example. I'll take two numbers 42 and 63 and I'll find out all the things related to these two set of numbers. So the first number that I've taken is 42 and the second number that I've taken is 63. If I have to find the factors or the divisor, there will be numbers which are less than n1 and which divides n1 completely. So I can just find out all the numbers, and such numbers are 1, 2, 3, 6, 7, 14, 21 and 42. Similarly, all of these numbers can be written in negative sense as well. So if I just count out, there are 8 positive and 8 negative factors that you have for 42. Similarly, for 63, the factors would come out to be 1, 3, 7, 9, 21 and 63, and in a negative sign as well. So if I have to look at the HCF or the highest common factor or the greatest common divisor, I'll look at the common factors. The first common factor is 1, the next common factor is 3 that I have, the other common factor that I have is 7, and the last common factor that I have is 21. So I look at the common factor and I look at the highest among these common factors. The highest common factor is coming out to be 21. So the prime factorization, if I just do it, this will be 2 raised to power 1, 3 raised to power 1, 7 raised to power 1, 3. This can be written as 3 squared into 7. So I look at the common things that I have. 7 is common and there's 1, 3 which is common. So I'll get an HCF of 21. Looking at multiples, it will be 41 into 2, 42 into 1, 42 into 2, into 3, into 4, into 5, into 6. Similarly, 63 into 1, into 2, into 3, into 4 and so on. If I look at the least number which is common in both these multiple series, that will be termed as LCM. So if I have to find out the LCM with prime factorization form, I'll just look at 2 is there, 3 is there maximum of twice, 7 is there maximum of 1 time. So this will be the answer that I'll have for a LCM thing. Let's look at certain questions related to factors and multiples. The LCM of two numbers is 120 and their HCF is 7. If one of the numbers is 12, find the other number. So if you remember the result, LCM into HCF is equal to the product of the two numbers. So LCM is given to you as 120, HCF is given to you as 7. One number is given to you as 12, you have to find out the other number. So you can probably cut the things and find out the other number. However, if you look at these two things, what we have just discussed is LCM is also a multiple of HCF, right? So if HCF is 7, LCM has to be a multiple of HCF. Is 120 a multiple of 7? No. So that means the data that has been given to you in the question is an inconsistent data. If I would have just solved the equation manually, I would get an answer of 70. But that is a wrong answer because LCM is not a multiple of HCF. This is a very, very important condition that I'll have to look at. LCM is always a multiple of HCF. Another question. The LCM of two numbers is 8. So if the LCM is 8, that means both the numbers would be multiples of 8. So I'll write the first number as 8k1 and I'll write the other number as 8k2. And I'll have to make sure that this k1 and k2 have nothing in common. That means their HCF is 1. If their HCF is not 1, the total HCF would not be 8. Which of the following can never be their LCM? Now I'll have to make sure that LCM would also be a multiple of 8. For sure. Is 24 a multiple of 8? Yes. Is 48 a multiple of 8? Yes. Is 56 a multiple of 8? That's a question that we have. And is 60 a multiple of 8? Which of the following is a multiple of 8? That is the only thing that I'll have to look at. So 56, if I look at it, yes, is a multiple of 8. And 60 is not a multiple of 8 that I have. So my answer would be which of the following can never be their LCM. 60 I'll mark as my answer option because 60 will never be the LCM that I will get. LCM has to be always a multiple of HCF. Very, very important thing. Third question. Raman wants to cut a rectangular board into identical square pieces. If the board is 18 inches by 30 inches, then what is the least number of square pieces he can cut out without wasting any of the board? Now, he wants to cut the least number of square pieces. If the number is least, that means the size has to be the maximum possible. The size has to be maximum possible. How would I cut it? Now, look at it. I'll basically find out the HCF of the two numbers 18 and 30. So if I look at the two numbers 18 and 30 and try to find out their HCF, I'll look at that their HCF is coming out to be 6. This is 6 into 3, this is 6 into 5. Excuse me. Sorry. This is 6 into 3, this is 6 into 5. So the HCF that I have is 6. That means I can cut a square piece with a size. This is, if I just look at 30 and 18. If I just cut it 6 cross 6. So this will be into 3, right? And this will be into 5. 1, 2, 3, 4 and 5. So if I just look at it, there will be so many square pieces that I'll have with the size of 6 cross 6. So if I just look at it, 1, 2, 3, 4, 5 and 3. So I'll have 15 pieces that I can cut out without wasting any of the board. Now whenever you get a question of this type, you have to keep into mind that this question is related to HCF. HCF means you are cutting something. Cutting means you are dividing something. That means when a division has to happen, the number has to be a smaller number. The fourth question that we have is LCM and HCF of this. This is a fraction question. So if I have to find the LCM of fraction, I'll find the LCM of numerators divided by HCF of denominators. So this is the question that I have. 3, 10 and 15. So if I have to find an LCM, I can do a prime factorization thing and I can look at the thing. 3 is there, 5 is there and 2 is there. 3 is there, the highest power of 3 is 1, the highest power of 2 is 1, the highest power of 5 is 1, divided by HCF. So the HCF of all of these numbers is 2. So if I just look at it, it is 15. That means these two answer options are anyways eliminated. And if I have to find out the HCF, I'll find out the HCF of 3, 10 and 15 divided by the LCM of 2, 6 and 4. So if I just look at this thing, this is 3, there is no common thing. This is 2 into 5, this is 5 into 3, this is 3. There's no common factor which is there in all of them apart from 1. Divided by LCM 2, 6 and 4. 4 is 2 square, this is 2 into 3, this is 2. So I'll take the highest part 2 square into 3, which is this. So my answer will be answer option B. We hope you've enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam-related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.